Hi everybody, welcome back. This is Unit 4 on the periodic table. This is Lesson 4. And today we're going to talk about two really important definitions in chemistry that you write on your chart every week. The first one is ionization energy. The second one's electronegativity. And I think I have the order mixed up. I'm actually going to present them. Electronegativity will be first and then ionization energy second. So electronegativity is a hard word just to say. A lot of times I'll just abbreviate it EN. So if I refer to EN, it's electronegativity. There's a table for that. So electronegativity is given to you on your reference tables. It's table S. And again, you have your word bank down here is your word bank. You can go ahead as I talk about electronegativity and fill in your words. So electronegativity is an atom's ability to attract electrons. It's how well that atom's positively charged nucleus can attract electrons from other elements. So I like to think of it as in a measure of attractivity, okay? Non-metals are really good at this. Metals are not. So that's why I say non-metal or metals are ugly and non-metals are handsome. Metals do not attract electrons very well. They don't have a good ability to attract their own electrons, let alone someone else's. Non-metals do. So an atom with a low electronegativity, like a metal like cesium, CS, does not attract electrons well, okay? Okay, so we'll write CS. Does not attract electrons well. However, an atom with a high electronegativity, like fluorine, F, has an electronegativity that is higher than anyone else on the table. F's electronegativity is 4, okay? That does attract electrons very well, okay? So cesium metals, really bad at attracting electrons. Fluorine, F, really good. It's a non-metal, really good at attracting electrons. The electronegativity values are given in table S. And you need to know the trend, just like you did with size, as you go down a group and as you go across a row. So hopefully you can see, if you look at this group, as you go down, it appears that the electronegativity tends to decrease. So as you go down a group, electronegativity decreases. And as you go across a row, in general, again, we can't, the weirdos are kind of hard to see here, but if you look here, as you go across a row, electronegativity tends to increase. Okay? For ionization energy, I think this chart's a little messed up. By the way, here's table S, and you can see here is your electronegativity. Okay? Ionization energy is different. Ionization energy is like stealing a purse. It's the energy you would have to put in to take away an element's electrons. Okay? So if that element, like fluorine, is really good at attracting them, you're going to have to put a lot of energy in to take its electrons away because it holds on to them really strongly. But if it's a metal that's ugly and doesn't really attract its electrons, you don't have to put a lot of energy in to take its electrons away. It loses them very easily. So ionization energy is the energy that must be added to an element to remove its outermost electron. An atom with a low ionization energy, like cesium, requires only a little bit of energy to remove its valence electrons. However, an atom with a high ionization energy, like fluorine, get rid of the F-L-U-O-R-I-N-E, get rid of the word only. Fluorine requires a lot of energy to remove their electrons. So the better they attract, which means high electronegativity, the harder it is to remove them. which means high ionization energy. High IE. That's how we abbreviate ionization energy, is IE. So EN's electronegativity, IE is ionization energy. And this is also given in Table S. And you also need to know the trend in ionization energy. The trends in ionization energy and electronegativity are opposite size, because smaller atoms attract better and are harder to take away electrons from. But bigger atoms attract worse and are easier to take electrons from. So it's opposite the size. So remember, as you go down, they get bigger. Well, it's easier to take away electrons from a big atom because they're farther from the nucleus. So as you go down the group, ionization energy decreases, just like electronegativity did. And as you go across the row, ionization energy increases. Because smaller atoms have greater nuclear attraction and that makes it harder to remove. So that's it, just those two important definitions, and then what happens to those two qualities as you go down a group and across a row. Remember, electronegativity is ability to attract electrons. Ionization energy is the energy needed to remove an electron. You do have a chart due tomorrow. Other than that, have a great night, everybody. Bye-bye.